Okay, so here's the setup for the Ohmic Login. Now in place of the Play-Doh, now we have put a single resistor, and we're going to do the same experiment with the hand crank generator, the ammeter and voltmeter. So let's go ahead and do that and see what we observe. Okay, so that inputs our data here, so let's take a look at it. And we notice that this data is very linear. It has an R value of 0.9967, so our R squared is going to be pretty good. And our slope is our resistance value, so 97.48 ohms is going to be the value of our resistor. And we can, the resistors have a color code that we can always think about and look up that tell you its resistance value. Okay, so now we're going to our next setup. Now it's the incandescent light bulb. Same thing as before. We're going to be rotating the hand crank generator, and hopefully we'll see what data we get here. Okay. So we saw the bulb lit up slightly. Now, looking at our data, we see that this is not linear. It's some other function that has some curvature. That means we can't really get a slope from this because our slope will not be correct from a point up here compared to a point up here. That implies that our resistance is increasing as the voltage and current get higher in the light bulb. And that is something to think about why that occurs. Okay, so this would be non-ohmic as described. So now the final part of our experiment is going to be the LED, light emitting diode. And we're going to again use the hand crank generator and see what we observe. Okay, that's in one direction. Now in the other direction, we're not seeing it light up. Now that's interesting. So let's look at our data. Now we see we have some data here. It's not quite linear, but it's close. But in the other direction, we didn't get anything, and we saw the LED didn't light up. So that would imply that it's only allowing the current to flow in one direction, and that is the basis of a diode.